Hello everyone. On this video we will be going over solving systems of linear equations using the substitution method. Okay, now before we get started, we're going to go over the three types of systems of linear equations. Okay, the first is the consistent system. And if you watch the video on graphing or solving systems by graphing, that's what we had there, because wherever the two lines would intersect, that's your solution. Okay, so with consistent systems, you have at least one solution. Remember, the key term there is at least one solution. Okay, so your inconsistent system do not have any solutions at all, and they will look like this. Basically, you have two parallel lines. Okay, so those lines could go on forever in either direction, and they would never ever cross each other. Okay, so since they never cross each other, they don't have a solution. Okay, and then the third would be your dependent solution or dependent system. That's where you have an infinite number of solutions. Instead of dependent solutions, say dependent systems. Let me correct that. Dependent systems. There we go. Okay, so dependent systems have infinite solutions. And that's where if you have your first graph and then your second line is directly on top of it. So basically they're the exact same equation. It's just a little minor difference. Okay, so basically they're the same but just look a little bit different. Okay, so to give you the overall details, remember a consistent system, you have at least one solution and both equations are independent, which means they're different from each other. They're not the same. Okay. Now for an inconsistent system, remember you have no solution. Let me see if I can clear that up a little bit. Yeah, it's a little better. You have no solution. Two lines are parallel to each other. And you have independent equations. The equations are two different equations, just the same slope. Okay. Now for a dependent system, you have an infinite number of solutions. The equations are identical. And you have a consistent system also. Because remember, for a consistent system, you have to have at least one solution. So for a dependent system having an infinite number, they also have at least one. Okay, so a dependent system is also consistent. Alright. So now let's go ahead and go through a few examples. Alright. So let's say, for example, we wanted to solve the system by substitution. And equation 1 is 2x plus y equals 10. And equation 2 is x equals y plus 2. Okay. Now when solving a system by substitution, you always want to isolate one of your variables. Okay. Now with this one, they actually did it for you. The x is already isolated. Okay, so since equation 2 is already solved for x, we're just going to replace x with y plus 2 in equation 1. Alright. So that means all you have to do is get your 2x plus y equals 10, which is your equation 1. And since we know that x is equal to y plus 2, we just replace it. So instead of 2x, we have 2 times y plus 2 plus y equals 10. Okay, so instead of having two different variables in the same equation, we now only have one variable. We only have y. So now we just go ahead and solve for y. Okay, so we go ahead and distribute that 2. So we have 2y plus 2 times 2 is 4 plus y equals 10. Okay, so now we go ahead and combine our like terms. So we have 2y plus y, which would give us 3y. So we have 3y plus, we get the 4 that's still there, plus 4 equals 10. So if we go ahead and subtract 4 from both sides, we have 3y equals 10 minus 4 is 6. So if we go ahead and divide both sides by 3, we have y equals 6 divided by 3, which is 2. Okay. Now, once you solve for that variable, you get that value and you plug it into the other equation. So since we started with equation 1, once we solve for a variable, we plug that into equation 2. So we plug y equals 2 into equation 2. Now, if we started with equation 2, we plug our answer into equation 1. It all depends on which one you start with. All right, let me move that up a little bit. So let me separate that. So now, instead of x equals y plus 2, we have x equals y is equal to 2, so it's 2 plus 2, which gives us x equals 4. Okay, so since x equals 4 and y equals 2, our solution is actually the ordered pair 4, 2. Remember, it's x comma y. Alright, so let's go ahead and do another example. Okay, so solving by substitution. Let's say if we wanted to solve the system where you have 5x minus y equals negative 2, and you have y equals 3x. Okay, so just like before, the first thing you want to do is you want to get at least one variable isolated. Here, the y is already by itself. Okay, so since y equals 3x, just replace y with 3x in equation 1. Okay, so again, we have 5x minus y equals negative 2. Since y is equal to 3x, we have 5x minus 3x equals negative 2. Okay, so we can go ahead and combine these two. So 5x minus 3x is 2x. So we have 2x equals negative 2. So if we go ahead and divide both sides by 2, we end up with x equals negative 1. Okay, so just like before, as soon as we solve for one of the variables, we plug it into the other. So since we started with equation 1, we plug this into equation 2. So plug x equals negative 1 into equation 2. Alright, so we go ahead and separate that. So remember, in equation 2 is y equals 3x. So since x is equal to -1, that's y equals 3 times -1, which gives us y equals -3. Okay, so your solution, remember it's x comma y, so it's -1, -3. Okay, that's where those two lines would intersect if you were to graph them, but you don't have to graph them because you can find the solution a much easier way. Alright, so let's do another example. Okay, so what if we wanted to solve the system using substitution, where we have x plus 2y equals 7, and 2x plus 2y equals 13. Okay. Now with this one, in order to use substitution, remember your first step is you want to get a variable by itself when using substitution. Okay. So here, there's no variable by itself. Okay. There is no isolated variable. So we make one. Okay. Now, since here you have an x, here if you have 2x and 2y, if you try to isolate those, you have a bunch of fractions. It will get messy. Here you have an x plus 2y equals 7. So if you have x plus 2y equals 7, if you subtract 2y from both sides, that would give you x equals 7 minus 2y, or negative 2y plus 7. Whichever one you want to use. Okay, so now the system you're going to use is x equals 7 minus 2y, and 2x plus 2y equals 13. Okay, so this is now the system you're going to solve. Okay, so if you want, you can draw a line through that just to remind yourself not to use it, but this is the one you're going to solve to use substitution. Okay, here, since the x is by itself, we're just going to plug in, replace x with 7 minus 2y. Replace x with 7 minus 2y, and that's equation 1, and that's equation 2. Okay, so that means, since we start off with 2x plus 2y equals 13, slide that up a little bit. Since we're going to replace x with 7 minus 2y, that's 2 times 7 minus 2y plus 2y equals 13. And just like before, we go ahead and solve for y. So we can go ahead and distribute that 2. 2 times 7 is 14, so you have 14 minus 2 times negative 2y is 4y. Then you still have your plus 2y right here, can't forget about that, equals 13. So we can go ahead and combine those two. And that gives us 14 minus 2y equals 13. So if we subtract 14 from both sides, that gives us negative 2y, I'll move that over here, equals 13 minus 14 is negative 1. So if we divide both sides by -2, we end up with y equals negative divided by negative is positive, so we have y equals 1/2. Okay, so we've already used equation 2. Now we plug this into equation 1. Plug into equation 1. Alright, so let me go ahead and separate that. So since equation 1, remember that's x equals 7 minus 2y. Since y is equal to 1/2, that's x equals 7 minus 2 times 1/2. Okay, so you can go ahead and cancel out those 2's. So x is equal to 7 minus 1, or just x equals 6. Okay, so that means your solution, remember it's x comma y, so it's 6 1/2. Okay, so that is your solution to that system. Okay, so pretty straightforward. So now what we're going to do is we're going to do a couple of, I guess you could say, unique systems. Okay, so if we want to solve the system by substitution, we have 1/2 x minus y equals 3, and we have x equals 6 plus 2y. Alright, so let me straighten that up. So if we're going to go ahead and solve this one, here, the x is already by itself. And remember, this is our equation 1 and equation 2. You don't have to put equation 1 and 2. I just do it for clarity. Make sure everything's nice and clear. Okay. So, of course, we replace x with 6 plus 2y in equation 1. Okay, the x is already by itself, so we don't have to worry about isolating anything. It's done for us. Okay, so that means we have 1/2 x minus y equals 3. We replace x with 6 plus 2y. That gives us 1/2 times 6 plus 2y minus y equals 3. Okay, so we can go ahead and distribute that 1/2 because we want to go ahead and try to solve for y. Okay, so 1/2 times 6, or 6 divided by 2, is 3. Plus 1/2 times 2 is 1, so we have 1y, or just y, minus y equals 3. Okay, so we can go ahead and combine those two like terms. Okay, so you have 3, but plus y minus y is 0. These two cancel out, so you have 3 plus 0, which is 3. So you end up with 3 equals 3, which is a true statement. Alright, so whenever all of your variables disappear and you're left with a true statement, then you know this is a dependent system. There are an infinite number of solutions for this. Okay? So, note, when all variables disappear, and you are left with a true, that's a very important part, true statement, then your system is dependent. Okay, so when you have a dependent system, you have basically, let me write this separately. Your answer would be infinite solutions. Okay, so that's how you would know if your system has an infinite number of solutions. Okay, so you go through and you go through all the steps properly, all your variables disappear, and your statement is true at the end, you have an infinite number of solutions. Okay, so let's look at one more example. Okay, what if we wanted to solve the system 6x plus 12y equals 5 and negative 4x minus 8y equals 0? Okay, so the one thing we can see here, if we wanted to solve this by substitution, there are no x or y value isolated, so we make one. So we isolate an x or y variable. Okay, so if we have, you can pick either one, I'm just picking this one, negative 4x minus 8y equals 0. Okay, so if we add 4x to both sides, we have negative 8y equals 4x. So if we divide both sides by negative 8, we have y equals 4 divided by negative 8. 4 divided by 8 actually simplifies to 1/2. So you have negative 1/2 x. Okay, so that means your 6x plus 12y equals 5, and that's your equation 1. And your y equals negative 1/2 x. That's your equation 2. Okay, so now this is the system you're going to solve. Instead of this one up here, again, if you want to, you can draw a little line through it so you don't mistakenly use that one. But right now, we're just rewriting that to look like this. Okay, so just like before, we replace y with negative 1/2 x in equation 1. Okay, so remember we have our 6x plus 12y equals 5. And since y is equal to negative 1/2 x, we have 6x plus 12 times negative 1/2 x equals 5. Move that up a little bit. Okay, so the 2 and the 12 cancel out. 2 goes into 2 one time. 2 goes into 12 6 times. So we have 6x. Then we have 6 times negative x. So that's negative 6x equals 5. So if we combine these two, 6x minus 6x, we get 0 equals 5. Which in this case is false. Okay, now if you notice the last example, all the variables disappeared and you were left with a true statement. So you have an infinite number of solutions because that's how you would have a dependent system. But when all your variables disappear and you're left with a false statement, then that's how you know you have an inconsistent system. Okay, so there are no solutions. Okay, so pretty similar to the last one. When all variables disappear, and you are left with a false, that's the key word here, statement, then your system is inconsistent. Okay, and by it being inconsistent, your answer is no solution. All right. Okay, so hopefully this made sense to you, and I will see you on the next video.